Good morning, students. Now we are going to see two-way classification. Already we have completed one-way classification. Now it is two-way. That is randomized block design. One-way classification is completely randomized design, CRD. Now randomized block design. Now let us see the definition. What is meant by RBD? A randomized complete block design is a restricted randomized design in which the experimental units are first sorted into homogeneous groups called blocks and the treatments are then assigned at random within the blocks. So randomized block design. Randomized block design means it is an experimental, that means it is an experimental unit or experimental design which are completely sorted, first sorted into a homogeneous groups. That groups are called blocks and the treatments, that means within the elements, all the treatments are arranged or assigned at random within the blocks. Okay, so we have two concepts. One is column and another one is row. Column, in column wise we have blocks, okay, and row wise we have the treatments. Now let us see the working rule. So first H naught working rule is same as a one-way classification, but here we have one step, that means one additional step, SSR is included. That means one-way classification means we are dealing with column only, SSC. Here column as well as row treatment. Okay. Working rule. First H naught. H naught means null hypothesis. There is no significant difference between rows and between columns. And H1 alternative hypothesis. Complement of H naught. There is complementary of H naught means null hypothesis. Now it is alternative. So there is a significant difference between the rows and between the columns. Next, third step, level of significance alpha. Fourth one, find n, capital N. That means the number of observations. How many number of observations are here in the question. Find T. Next step, find T. T means the grand total of observations. Next, find correction factor CF. CF is equal to T square by N. From the above two steps, we get correction factor. The next, calculate the total sum of squares TSS. Total sum of squares is equal to, here it is the formula summation x1 square plus summation x2 square plus summation x3 square plus etc. minus T square by N. The next, calculate the sum of squares of columns SSC. All the terms, all the steps are same as one-way classification. Now SSC, where N1 is the number of elements in each column. That means we have column wise and row wise elements. So SSC means column. N1 is the number of elements in each column. The next ninth step is the additional step. Here two-way classification. So calculate the sum of squares of rows. SSR. So summation y1 the whole square by n2 plus summation y2 the whole square by n2 plus summation y3 the whole square by n2 plus etc. minus T square by N. It is the correction factor. T square by N is the correction factor, where N2 is the number of elements in each row. That means treatments. Row wise we are arranging the elements which is N2. The next, find the sum of squares of error. Next step, SSE. This is the notation. These are the notations. Short form SSC, SSC, SSR, sum of squares of rows. Sum of squares of error, SSE, is equal to TSS minus SSC minus SSR. This is the formula. The next 11th step, construct the ANOVA table. ANOVA. So ANOVA means analysis of variance. Here in this chapter, throughout this chapter, we are dealing with the variance only. Variance. So already we know in the first unit we have mean, variance, standard deviation, etc. So variance means F test. F test. Okay, so throughout this unit we have F test only. So we are using the F table values only. Okay, mean That means differences in mean means that is t test. Differences in the variance means that is f test. Construct the ANOVA table and compute calculated f and find tabulated f. Tabulated value f, that means table value using the degrees of freedom and alpha. Third one, 13th one, conclusion. So finally we have ANOVA table and all the values SSE, SSR, SSEL already we have calculated. Here are all the values and substitute all these values in a table form, that is the ANOVA table. Tabulated value f, that means table value using the degrees of freedom and alpha. Third one, 13th one, conclusion. So finally we have ANOVA table and all the values SSE, SSR, SSEL already we have calculated. Here are all the values and substitute all these values in a table form, that is the ANOVA table for two-way classification. SV, source of variations. SV we have between columns, between rows and error. SS, sum of squares. So sum of squares of column, sum of squares of rows, sum of squares of error. The next DF, degrees of freedom. So degrees of freedom C minus 1, R minus 1. C means it is the column, C minus 1. R means row value, row minus 1. That means number of rows minus 1. And T is equal to C minus 1 into R minus 1. Next MS, mean square. MS means mean square. So mean square formula, let us take this is 1 and this is 2, second column. So MS means first column divided by second column. So MSC is equal to SSC by C minus 1. MSR, SSR by R minus 1. MSE, SSE by T. The next calculation, calculated F. Here we have two values for F and two conclusions. Okay, already we know the two conclusions are, one is rejected, otherwise accepted. So like that, calculation F. If MSC is greater than MSC, all the values are compared with error. Okay, so we are comparing the column values with error and row values with error. So MSC is greater than MSE means F is equal to MSC by MSE. And if MSE greater than MSC, F is equal to MSE by MSC. And similarly MSR, if MSR greater than MSE, F is equal to MSR by MSE. And if MSE greater than MSR, F is equal to MSE by MSR. The next table value, tabulated F, F alpha. Here MSC is the greatest one. So that degrees of freedom is C minus 1. First C minus 1, comma, error degrees of freedom T. The next here MSE is greater than MSC. So MSE degrees of freedom T, comma, MSC degrees of freedom C minus 1. The next error, comparison with the rows, MSR. Next F alpha. Alpha means level of significance and this is the degrees of freedom. R minus 1. If MSR greater than MSE, so degrees of freedom is R minus 1 comma T. F alpha, MSE greater than MSR. So MSE degrees of freedom T and MSR degrees of freedom R minus 1. This is the ANOVA table. And throughout this unit we have this ANOVA table, and for one-way classification, two-way classification, three-way classification, and this is the important unit. Questions, all the questions are 16 marks. Each question carries 16 marks. Okay, now we will see the problem. Now let us see the problem based on two-way classification. An experiment was designed to study the performance of 4 different detergents for cleaning fuel injectors. The following clean lines reading were obtained with the specially designed equipment for 12 tanks of gas distributed over 3 different models of engines. We have engines 1, 2, 3 which are arranged in column wise, and we have detergents and 3 A, B, C, D. 4 different detergents for cleaning the fuel injectors of these engines. So detergents, that means detergents are arranged in row wise and engines are arranged in column wise. So it is two-way classification. And here the total values. Perform an ANOVA table and test 0.01 level. So it is mentioned in the question, level of significance is 1%. Okay. If not mentioned, we usually use 5% level. If the level is mentioned, we use the particular mentioned LOS, level of significance. So now here LOS 0.01, perform the ANOVA test and level 0.01 of significance, whether or there are differences in the detergents or in the engines. So if any differences or variations in engines or detergents, we have to check it. Solution. So first analysis, two-way classification. So we have to test whether there is a difference in the detergents or in the engines. So we use two-way classification. First null hypothesis, H0, there is no significant difference between columns, that means engines. There is no significant difference between rows, that is detergents. Okay. Otherwise you write there is no significant difference between columns and between rows. In a single line we can write. The next H1, alternative hypothesis, there is a significant difference between the engines and the detergents. Okay. Next LOS, level of significance, it is mentioned in the question, 1%. Now to simplify the calculations, here all the values are the largest one, that means 45, 43, 51, all are the largest values. So if you take the square, it is again the larger, and the total sum again it is the 6-digit or 8-digit values. It is a 2-digit value. If we square this one, we get 4-digit or 3-digit. Then the total value, it becomes too large. So for simplification, we can use one simple easy way, that is we choose to simplify our calculation, we code the data or subtracting, we choose any of the values from the given datas. From the given values, we can choose any one of the value and subtract the particular value with all the remaining values, all the values including the particular 50 or 48, anyone. Subtract all the values within the blocks or treatments. So the calculation is easy. Okay. To simplify the calculations, we take 50 and subtract this 50 from each number. So engines, and here the engines are mentioned x1, x2, x3, column wise, and detergents we have A, B, C, D, row wise y1, y2, y3, and we need and the total value, then x1 square, x2 square, x3 square. Here we are taken 50. So 50 is the common origin. So subtract 50 from all the numbers including this 50. Okay, subtracting 50 from all the numbers. So 45 minus 50, 43 minus 50, 51 minus 50, 47 minus 50, 46 minus 50, like that. Okay, so we get the single digit value, single digit number. So when it when we square the number, it becomes double digit. Then add, we get the total values. So then here the row total, then here it is the column total, then row total and column total value must be the same one. Okay, row total and column total are same, that is we consider or we take that one is T, capital T, that is T is equal to minus 35 here. Then x1 square, x2 square, x3 square, it is easy, that is the square values minus 5 the whole square 25, 7 square 49, 1 square 1, like that. Then add all these values, we get the total. Then here n means what? N number of observations. So number of how many number of observations we have? 3 engines and 4 detergents. So 12. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of observations 12, and t is the total number of observations. So total value t is equal to minus 35. Then find the correction factor CF is equal to t square by n, the formula. Then we get CF correction factor. Then TSS, total sum of squares, summation x1 square plus summation x2 square plus summation x3 square minus t square by n. This is the formula. Then all the values are calculated here. From the table we can get summation x1 square is 102, summation x2 square 234, summation x3 square 31 minus correction factor t square by n. Then simplify, we get to 64.9295. Then find the correction factor CF is equal to t square by n, the formula. Then we get CF correction factor. Then TSS, total sum of squares, summation x1 square plus summation x2 square plus summation x3 square minus t square by n. This is the formula. Then all the values are calculated here. From the table we can get summation x1 square is 102, summation x2 square 234, summation x3 square 31 minus correction factor t square by n. Then simplify, we get to 64.9292 TSS. Then SSC, sum of squares of column, summation x1 the whole square by n1 plus summation x2 the whole square by n1 plus summation x3 the whole square by n1 minus t square by n. Summation x1 total. So summation x1 total is minus 18, summation x2 total minus 24, summation x3 total 7, the whole square by 4. 4 means number of elements in each column. So in each column we have 4 elements, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So in each column we have 4 elements. So n1 is 4. Then simplify, we get SSC value. Then SSR, summation y1 the whole square. These are all the formulas we already seen in the procedure, okay, to a classification procedure. So summation y1 the whole square by n2 plus summation y2 the whole square by n2 plus summation y3 the whole square by n2 plus summation y4 the whole square by n2 minus t square by n. That is SSR means we have row values. So we have 4 rows, y1, y2, y3, y4. That means 4 detergents. The detergents are arranged in row wise and engines are arranged in column wise. So from the table we get summation y1 total is minus 11, y2 total minus 5, y3 total 3 and y4 total minus 22. All the values are substituted here and simplify, we get SSR value. And then SSE, sum of squares of error. SSE, total sum of squares TSS minus sum of squares of column SSC minus sum of squares of row SSR. So we get SSE value. Then finally we have the ANOVA table and all the particulars are entered in a table form, that is ANOVA table. All the values substitute here. Source of variation SV, between columns, between rows, and here are sum of squares of column SSC, SSR, SSE. Then degrees of freedom DF, C minus 1, column minus 1, R minus 1, row minus 1, and T, C minus 1 into R minus 1 degrees of freedom. Then mean square, MS, mean square values. So MSC is equal to, what is the formula? This is, we can take 1 and this is 2, so 1 by 2. That means SSC by C minus 1 and MSR is equal to SSR by R minus 1 and MSE is equal to SSE by T, that is C minus 1 into R minus 1. Substitute all the values, then divide, we get the answers MSC, MSR and MSE. Then calculated F, calculated value. That means variance ratio are calculated F. Here all the values are compared with the error. That means a mean square column MSC compare with the MSE. So here MSC value is 67.59, MSE value is 3.14. So MSC greater than MSE. So formula is FC. F value with for columns FC is equal to MSC by MSE. So we get 21.52, and second one row value compare with the error. So MSR 36.97, MSE 3.14. Here also MSR is greater than MSE. So FR is equal to MSR by MSE. We get 11.77, and last table value, and the question itself it is mentioned the level of significance is 1%. Okay, so level of significance is 1%. Then MSC greater than MSE. MSC degrees of freedom is 2, and MSE degrees of freedom is 6. So table value F test F at 1% level 2,6. The value is 10.92 from the textbook. And MSR greater than MSE, second one. So MSR degrees of freedom is 3, and MSE degrees of freedom 6. So F test at 1% level with degrees of freedom 3,6. The value is 9.78. Last conclusion. So we have two conclusions. Conclusion for column and for row. That means if there is any differences within the engines or within the detergents. Okay, so we have two conclusions. Calculated value FC is greater than table value. So first conclusion for within the columns, that means within the engines, calculated value is 21.52 and table value is 10.92. That is calculated value is greater than table value. So we reject H0. So we reject H0 means automatically we accept H1. That means there is something differences in the columns or in the engines. So we have three engines, X1, X2, X3, three different varieties of engines. So there is a significant difference between the engines or columns. And the next conclusion, calculated FR is also greater than table FR. Calculated F value FR 11.77 and table value 9.78. So FR is greater than F alpha table value. So here also we reject H0. That means there is something differences in the detergents also. So we have four different detergents A, B, C, D. So within the detergents there is something differences. So we reject H0. There is a significant differences between the detergents. This is the conclusion for our